his house just like much.
Okay, here we go.
Definitely never.
Hey, quiet, please. Get ready. Come back now. Okay, everybody look up. Everybody look up. Ella, come back. Ella. Okay, look. This. We lost another one. There we go. Okay. Listen close. Okay, we spent, I don't know, 4 class days studying limits. Pretty efficient, actually. About 10% of the points on the AP test will come from that topic. Okay? About 10%. So you have a really good head start on the AP test. There's a few other limit ideas we will learn kind of along the way, but we won't really have another solid day or anything on just limits, okay? The new topic, however, is even more important than limits by a long shot. So limits are kind of a little standalone item that we reference, but again, about 10% of the test will have some problem that deals with limits. The other 90% of the test will have problem after problem that deals with this. Hello. The other 90% of the test will have problems that deal with one of these 3 things. Either an amount, a rate, or a rate of a rate. Okay? Here's a really simple example of what we mean by amount, rate, and rate of the rate. If you have a big tank of water, and there's some amount of water in the tank, the amount in the tank is self-described. It's what we're calling the amount right here. Like, how much water do you have in the tank? I've seen AP problems where the amount is simply the temperature of a room. I've seen AP problems where the amount is a number of bacteria in a dish, but it's just a quantity. It's like how many of something. You know, how many degrees of temperature do we have, whatever. So that's amounts. Rate is also pretty simple. If you put a valve on the bottom of the tank and you let water leave the tank, the water is going to flow out at some rate. That means this level, the amount, is going to drop. It's going to be dropping by, in this example, 10 gallons every minute. So 400 gallons is the amount of water in the tank. Basically, this would be negative. Negative 10 gallons per minute is the rate at which that amount is changing. Questions so far? Whoa. If you turn the valve,
is there going to
which one are you missing?
the yellow one?
That's right here. That's right. You're welcome. If you turn the valve and you let more water flow out, now another thing is happening. The rate itself is changing. So the rate may change from negative 10 gallons per minute to negative 11 gallons per minute to negative 12 gallons per minute. And therefore, in this simple example, this is the rate at which the rate is changing. Although this again would have to be negative because the rate is becoming increasingly negative. So that's the 3 things we're going to study. Tara, please.
So the rate of the rate is the -1, not the -11?
Correct.
Okay.
What I was illustrating, 2 points for Tara, is you have an amount of water. If that amount is dropping, it's going to be dropping at some rate. So we say, well, maybe in the beginning it's dropping by 10 gallons every minute. So this tells us how fast this amount will change. So this is the amount, this is the rate. But then if you make the rate change also, this describes how fast the rate is changing. Anybody else? Okay. This topic is far more important than limits. This idea of understanding amount, rate, and rate of the rate. We have a chart here to help us understand how these 3 things relate to each other. I did not invent the chart. I have to give credit to a student I had the very first year I taught calculus. The way I was taught calculus was to understand these relationships just by like sentences on a page. And then the student late in the year, I noticed her using this little chart like this, and I was like, wow, that's really helpful. Her name was Danica Wright. She actually sat right here in A2. And I asked her if she would be okay if I used that chart forevermore. And so I named it after her. There's a picture of it on the wall. We call it Danica's chart. There will be no single item really in calculus that you will remember more than this chart. It really helps on many, many problems. So, you'll have to have it memorized, but you really don't have to work to memorize it. It kind of comes naturally as you do the homework. So, questions?
Should we copy this down?
You don't need to yet. When we start using it, we'll have another copy, so you're okay. 2 points for Aspen. Anybody else? Right. Okay, the amount, rate, and rate of the rate that I just showed you involved a tank of water, water leaving the tank, and then the rate of that water changing as it leaves the tank. The packet is all about a moving object. Now, for our class, when we talk about a moving object, it's really very simple. The object can only move back and forth or up and down. It won't do both. So you might encounter a problem where the object is moving back and forth. You might encounter a problem where the object is moving up and down. You will not encounter a problem where you have to simultaneously keep track of both necessarily. So, another little gift from students. To describe what's happening here, I found it helpful for all of you for me to stand in front of the room and tell you that, as the hat declares, I am the particle. So put on the hat, become the particle. It's very exciting. Okay. Yeah, not really a big hat wearing person. Okay. So, again, for the purposes of this discussion, I being the particle, I only move back and forth. So where the projector is located is the center of my line along which I move. You need to memorize that this is known as location 0. It's not time 0. I might be over here when time is equal to 0. That spot over there is still location 0. Like here's location 0, here's location, I don't know, -20. Here's location -40. Here's location +20. Questions? Location 0 has another name. It's known as the origin. You need to memorize that. That will show up on the AP test over and over again. They'll say something about the origin. Origin means location 0. Okay? Questions? Please ask.
Where is location 0? Is it at x equals 0 or?
It can be a little confusing, 2 more for Aspen, because on this graph, you don't want to think of this as the particle at all. If you look at this and think particle, it's going to cause you trouble. When you think particle, you must think of me. Like I'm the particle, I just move like this. The graph is just a collection of numbers that describe what happened to the particle. So location 0 is simply right here. It's not here.
It's not on the graph?
It's not on this graph at all. Well, it is, but it's not the way you're thinking of it. Let's keep talking. You'll see it. Let's do this. Look. So you have this right here, so you can reference it. It's also in the front of the packet, but I thought it'd be helpful to have a separate sheet, so you don't have to keep flipping the packet back and forth. So look here at time 2, trying to answer this question. Okay, the blue graph is representing the position of the particle. On the AP Calculus test, they like to use the symbol x of t to represent position. So If I'm looking at time 2, I would be talking about the position of the particle at time 2. And this graph will tell me the position of the particle at time 2. I simply identify the dot of interest, and I notice that that dot will have 2 numbers associated with that dot. Look at your chart here. Raise your hand, I'll pay everybody. What are the 2 numbers that are associated with the dot that I just drew on the board? Hands up. It's just reading a graph. Again, this isn't, don't look at this and think particle. The particle is not displayed here. This is just a dot that has numbers connected to it. So what are the 2 numbers, MJ? Nicely done. So we'll kind of make a rough and just say, oh, looks like negative 25 sounds good. So this is 2, comma, negative 25. Raise your hand, please, if you would have said that if I'd called on you. 0.2 for MJ. Okay, hands up again. What is the 2 representing? Come on, hands. What is the 2 representing, Blake?
The position.
2 points, but no. Preston, what's the 2 represent? Oh, no worries. Point for Preston. Xander.
Time.
Time. 2 is the time. How many knew? 0.2 for Xander. Look. Gotta keep reminding you, don't look at the board and think particle. It'll cause errors. It'll cause trouble. Get you all confused. Look at the board and just think numbers. And then interpret what the numbers represent. So the 2 represents 2 seconds into the particle's journey. Okay, it's like it's keeping track of things about the particle at different times. Please ask.
So at 2 seconds, it would be at negative 25, whatever you
Perfect, perfect, perfect. So here's location 0. That means location negative 25 is over there. 25 meters that way.
So location 0 is where y is 0
So in this graph,
on the blue?
if we go right here, much better, Aspen. Everybody raise your hand. What are the 2 numbers associated with that dot? Hands up. Just do your best. You can look at your white sheet. What are the 2 numbers, Sam, associated with that dot?
It's like 6.4 and 0.
How many knew? 0.2 for Sam. Hands up. What does the 6.4 represent? Let's go over here.
The time.
How many knew? 0.2 for Lucas. What does the 0 represent, Lucas?
I guess like position on the line.
The position of the object as it moves back and forth. How many knew that? Point. So Aspen is correct. The particle's moving all over the place. Like I'm the particle, I'm moving. Precisely at 6.4 seconds, 1 second HT, 6.4 seconds into my journey, I'm going to be right here.
And that's the origin.
That's what they call the origin.
Okay.
So origin has nothing to
It's
do
not
with,
where they start, it's
Correct.
where they're at 0.
it's when they are at location 0
Yeah.
along this path.
Okay.
Does that help?
Yeah.
It's much
So
better.
could I
2
have
more.
2 more?
HT.
Okay, so if the y value is the position of the graph, could you describe the movement of the particle by just condensing it all into a single line?
Oh, wait.
If you don't think about the x at all, just if you get rid of the time, take the blue graph and make it a single vertical line.
Let me say it back to you. I think you are dead correct. I just want to make sure you and I are thinking the same. If I follow the blue graph, which is the position graph, and I ignore x coordinates, and I just read y values, I will be reading the positions of the particle. Like literally, I'll just kind of estimate. Like right here, the position would be negative 10. Right here, negative 25. Right here, negative 60. Is that what you meant?
Yeah.
Yep, that's perfect. 2 points. Please, Preston.
I got it.
You're okay. 2 points. Please, Gabe.
So anytime it crosses the x-axis, it's at position 0.
Everybody listen. 2 points for Gabe. Be careful to never use another forbidden word. Okay? Reese Curtis made that one. On the AP test, there are lots of questions that will ask you to look at something like this, where you are simultaneously keeping track of the amount, the rate, and the rate of the rate. If you say the word "it," the grader can't tell what you're talking about. So just saying back what you said, Gabe, if I'm looking at the position graph, right here, you are correct. Every time the position graph touches, doesn't have to cross, but touches the x-axis, the particle will be at location 0, which is also known as the origin. Is that what you meant?
Yes.
There could be multiple origins? Oh, type, right.
The way you want to say it is there can be multiple times in the particle's journey where the particle is at the origin. Because origin, like Aspen said, does not mean where the particle began. It's just this location along its path. Does that help?
Yeah.
Two for Nadia. Please answer.
Why don't we just call it x-axis?
Points for MJ. Searching for the reason. The biggest reason, honestly, is that the AP test writers use a certain type of language, and I want you to get used to the language that they use, so that when you're taking the test, you know exactly what they're talking about. And what they will say, hey, look at me, come on. You've got to be careful again. I kept mentioning this to Aspen, 2 more for her. This graph has an x-axis. They're going to say the particle moves along the x-axis. Those are 2 different versions of the x-axis. So don't get in your head that the particle is moving along this line. It isn't. The particle is moving along this line on the floor. Like I'm the particle. I don't move along that blue line. I move here on the floor. They're separate things. Don't combine them. Okay, this is where I'm moving back and forth on the floor. The AP test will say I am moving along an x-axis. Well, that's because you could draw a line on the floor and call it an x-axis. This is a different horizontal axis. This is the time axis. That's because this isn't the particle, this is just numbers talking about the particle. Please.
So what you're saying is you don't want to get confused and think that the x-axis represents distance instead of time.
Correct. This x-axis represents, in fact, I'm not going to call it the x-axis, I'll just call it the horizontal axis of the graph. It only represents time. And it's just a way to write down a bunch of information about the particle. 2 more. Else. Sweet. Okay. So, answer this question. You're heading right down the right path. Raise your hand, please, if you can tell me. At time equal 3, there's only 3 options. You're going to vote. Look. 0, like this. Okay, 0. 1, you're just going to vote. This means 0. I'll give you the question in a second. This means 0. This means 1. This means 1. This means 2. That's dumb. Laughter is appropriate. Okay. That was stupid. Okay, look. 0, 1, 2. 0 means the particle is stopped. It's not moving. We'll use 1 to represent the particle moving to the right. We'll use 2 to represent the particle moving to the left. I would like you to show me on your hand at time equal 3, what's the particle doing? Like we've been talking about the blue graph, which represents the particle's position. If you understand how to read that graph, you can answer the question. Is the particle at time 3 stopped, moving to the right, or moving to the left?
Which one is positive?
Say again.
Which right or left is positive?
Oh, gotcha. So it's for you staring at the graph, to the right is positive, to the left is negative. 2 points. Show me your vote. So at time equal 3, you can look at the white sheet if you need to. Is the particle stopped? Is it moving to the right, or is it moving to the left? Everybody gets a point for voting. If you did this, you get 2 more points. Okay, watch. Watch. Look. You don't look at the, like this isn't the particle, this is just numbers talking about the particle. So at time equal 3, raise your hand please. I'll pay everyone. What 2 numbers are associated with this dot? Yes. what two numbers are assigned to that dot? Let's go, Matthew. So 3 and negative 78. Okay, raise your hand, please, if you would have said that had I called on you. Point 2 for Matthew. Somebody else, one person, hand up. What is the 3? What is the negative 78 telling us? What's the 3? What's the negative 78 telling us? Let's go, Kennedy Bennett. And the negative 78? It's the position at that time. The particle's moving, time's going by as it moves. At time equal 3, particle's over here on the left, 78 meters from the origin. Questions? 2 for Kennedy. That's what the two numbers are telling you. Okay, now an idea that's kind of like limits. If we go forward in time, a infinitesimal amount, raise your hand, please, and tell me, will the position be the same, more positive? Yeah, sorry, will the position be the same, more negative, or less negative? Hands up. Like we go forward in time, an infinitesimal amount. Is the new position, that infinitesimal amount forward in time, going to be still negative 78? Will it be more negative, less negative, Caitlin?
Would it be more positive because it's moving?
So we're here, right? So we're looking at this blue graph. The blue graph is a.
Line goes up that way.
No, stay with me.
Okay.
The blue graph is a bunch of numbers talking about the position of the particle. You with me? Okay. At time equal 3, the particle is 78 meters that way from the center.
Okay.
If I go forward a tiny amount of time, I imagine I can draw this green dot.
I was thinking.
Oh, I thought you were saying forever.
Instantly.
Right. Let's start over. No worries.
Okay.
So, hey, is it better understood now what I'm talking about?
Yeah.
Awesome. That's what 3 plus means. It's like just a little bit more than 3. So hands up again. There we go. Is the particle, is this position here going to be more negative than this position? Is it going to be the same as that position? Is it going to be less negative, Caleb?
That would be more negative.
How many knew? Point 2 for Caleb. So more negative is kind of a little weird to write, but you write it like that. More negative, So if the particle has a position that is more negative, say it out loud. Is the particle moving left or right? Say it. It's moving left. Right here, the particle is moving left. HT, please.
Can I go to the bathroom?
Yeah, you good. Anybody else?
So,
Please.
Kayla just mentioned this, but to kind of flip the graph like to the side in your head, would that work in most cases? Just to kind of like look at it in a different way, so instead of like, as it's going more left or more down, it's going more left.
I believe, I don't ever do that, so I have a hard time doing it. My head, I just have learned to do that. But I believe you are correct, because if the particle's moving up and down, now the graph kind of resembles what the particle does.
Yeah.
Like, the particle still, listen close though, hey. There you go. The particle still, how do I say this? Like if you do this, like you guys are doing, like,
Yeah, there's a part where like it was still
yeah, you
going.
can't really flip it because it's, never mind.
That's still going.
Look,
It's going right now.
it's pretty simple. Just there, pick up some points, answer this question out loud. I'm going to point to a dot right here. Is the particle left, right, or at the origin? So left, right, or origin? Say it.
Left.
Good. Is the particle now more left or less left? Say it.
More left.
More left. It's more negative. It's more left. It's easy to read. It's just more left, okay? Questions? Please.
What happens at the bottom where it switches from going left to going right?
So right here,
Did you say it's like temporarily stopped or?
it stops.
Okay.
It has to. 2 points for each of you. But that is the time, in fact, raise your hand please and tell me, what is the time when the particle is as far left as it will ever go according to this graph? What is the time, Jake Beck said, when the particle is as far left as it will ever go?
Like 4.9 seconds.
Yeah, and it's actually marked on the white table there. What does it say there, Jay?
4.8.
2 points for Jay. Okay, look. That is the moment when the particle is as far left as it's going to go. Watch me, watch me. If I'm the particle, and I don't have enough room to go way over there, so just pretend this is as far left as I go. One tiny amount of time earlier, I was here. Good? Now I'm here. One tiny amount of time more, I'm going to be back here again. Because I was moving left, I was doing this, I was going to the left, still going left, still going left, still going left. When I get to 4.848, I have gone as far left as I can go. So I must stop for a instant. There's no time elapses. Like I'm just stopping for an instant. The very next instant, I'm here. Now I'm moving to the right. Questions? Please, please.
So when it like stops like that, do we look for that in like graphs like these to determine whether it's going left or right?
Yes. Hey, it's pretty simple. My position along here, raise your hand please. For these dots that I'm now drawing, just raise your hand if you can answer it. Is the particle on the left side of the origin, or is the particle on the right side of the origin? Hands up. Hands up. Like, where's the particle for these dots right here? Is the particle on the left side of the origin or the right side of the
Still on
origin?
the left side of the
Still on the left side. How many knew? Point, 2 for Blake. Still on the left side because its position is negative. Questions, please.
Is it considered on the left or right side when it's on, I hate to say this, but the like
You're okay.
very x-axis? Is it stopped there?
Yeah, because the horizontal line here is the marker for the origin of the particle's movement.
Okay.
Origin not being where it began, but origin meaning location 0. 2 points, please.
What about the time like further left of like 0 seconds? Like negative.
Like over here?
Yeah.
On the AP test, they won't really talk about time being negative, but it's not a complicated idea. It's just that, hey, we're going to call this where time begins. So this was just 1 second earlier. That's all. So along here, hands up again, 2 for Claire. For these 3 dots, hands up. Is the particle on the right side or the left side of the origin? Hands up. Will.
The right side.
How many agreed? Point 2 for Will. Because all these points have positive y values. The y value is the location of the particle. So it's over here. How many knew? Point. Okay. Look. Hands up. Along here, along this path, for this section of time, is the particle going to the right or is it going to the left? Hands up. There we go. Let's go, Ella. It's going. I cut you off. I apologize. Yeah, it's going to the left. How many knew? Point. 2 for Ella. Because its position is positive, but is becoming less positive. So it is on the right-hand side of the origin, but is moving towards the origin. Tara.
So that part where it hits the origin, it just kind of chills at location 0 and then goes negative.
2 more points. For this class, you can be assured that if what you look at is curvy, there is no flat spots. So it's just we're not zoomed in close enough to see that it isn't flat.
It's just moving really slowly.
Really slowly. Very true, very true. It is moving just slowly. 2 points.
So at 6.4, 0.
Say it one more time,
At
Kate.
6.4, 0, would you just say it's at the origin instead of saying
It's at the origin.
left or right? Because you can't say it's stopped either, because it's not. It's still. Sorry, the particle.
Let me say it back to you. You've got it. So at time 6.4, what's the y coordinate right here, Kaylee?
0
Good. So at that moment, where is the particle located?
on the origin.
At the origin. Hands up for the whole room. At that moment, which way is the particle moving? There we go. Xander.
It's moving right.
So the position is 0 at that exact time, but the next position is more positive. The next position is even more positive. So it was at the origin at time 6.4, but it is moving to the right. How many knew? 2 points, 3 for Xander. Kayla, please.
That's still not quite.
That's okay, say it again.
So those are at the next points, like later on. What would you call it at that specific point? Just don't say anything.
No, you're doing great. Like what aspect would you, when you say what would you call it?
So we're naming all the other ones. We're saying it's either stopped, it's left, or it's right.
Oh, let me say it back to you. I think I got it. 2 more for you. Let me say it back. What they'll expect you to understand is basically 2 things about the particle. One, where is it? And where means, is it over here on the right side of the origin, or is it over there on the left, or is it at the origin? So you've got to know that. And then it wants to know which way is it moving. So at time 6.4, it's at the origin. It isn't stopped. It's moving right. Was that what you meant? It's much better. Okay, everybody look. Questioning, superb. Like, it's so easy. It's starting to feel like BA. True? Yeah, a little bit.
A little bit.
A little bit. Look, hey, look. The key is this. Like, I have to sense that you are probing to make sense of it. That you're not just passively waiting to, like, kind of copy whatever I do. Like, when you're searching for the meaning in it, then I know you're on the right track. And once you understand it, memorizing it becomes way easy. It's hard to memorize if it doesn't make sense. Okay? So just keep talking the way you're talking. Question. Please.
Would it kind of help to like imagine it as if this were like someone, I don't know, walking, and like that side is like them doing that, like just like how you've been doing it, but like imagine it on the graph.
If it helps you, do that.
Okay.
It's not a bad idea in the sense that you can say, okay, yeah, it doesn't help me, but it helps you. Do it for sure.
Sorry.
You're good. 2 more.
What does the C and C stand for?
Oh, we won't discuss those today yet, Jake. 2 points for asking though. They are abbreviations for concave up and concave down.
Whoa, what the?
2 points if you made a gesture. Write that down.
I did that to Coach British. She was like, I think you run for that.
We'll talk about that, just not quite yet. So, other questions? Sweet. All right, where are we at? Okay, next thing, we got to make sure everybody can use their calculator properly. I'll be straight up honest with you. We're going to use the calculator for a couple of days. I do that early in the year because I want to make sure everybody has the right calculator, and then when we start using it heavily, it isn't like, oh, I don't have a calculator. Because there's only so many rentals available, and so if you need to rent one, I want to make sure you get it, okay? But we won't use the calculator really for a while after this couple of days, okay? I need you to do this on your calculator to make sure everyone knows how to use it. I need you to go to the y equals and enter these 3 equations that are listed on the blue packet. So do that, go.
So instead of T, we put X.
Correct. In the calculator, we use X as the horizontal variable.
If you wanted to find what time it's at the origin, could you just plug in, like, the whole equation equals 0?
Yes, that is correct. Because, hey, Preston's right. This equation is calculating a location for whatever time you plug into the equation. So if you say, I want that equation to be 0, you are saying, I want to figure out what time will cause that to happen. And I guarantee you that if you plug 6.4, well, roughly, into this equation, the result will be 0.
Yeah.
Is that what you meant?
Or you put 0 instead of the X and T, right?
Let's talk
And then
about that.
you solve for time.
Not quite.
Or would you just have to factor the equation?
Oh, solving that by hand is
No.
no bueno.
No.
Yeah, we'll do it on a calculator. I don't want to even try. I'd have to dig out. I'd have to go to Google and say, how do you solve this? And there may not be a way. So there probably is, because people did stuff without calculators for forever, but I don't. I use my calculator.
Yeah.
2 more. Question. Okay, get those in your calculator. If you need help, call me over. I'll help you. I gotta start up my calculator again, it crashed. Oh, I'm a dumb board. Close already. I gotta get my calculator going again. Hold on a second.
Calculator go first.
You guys have been doing
Oh, it's what?
It's your window. Doesn't even know what window it is. It's pretty saturated. What?
It's, you wanna know what's that?
You know what window it is?
I know it.
What is it? This guy. Calculator window. See when I press it.
There we go. Yeah, it's
I was like, well, I don't.
Yeah.
What am I gonna do?
That, yeah, he knows what it's talking about. Pressing says blue, so
You need me to help them? Calculator guide as well? Another boner?
you got it. Although I do not know plus 8. The windows are 140. Plus 80%. That's Jeff. How much you want? Why would you want to do homework? Mine was just $1,000. We have bigger problems.
Well, see, my boss,
How much you got?
That's some people's favorite parts, but.
actually.
Success.
Chad Daddy's money individual.
What's reason? He's a diesel. That's like 2 guys. That's like 2. Because my car was 7.
Hey, look up. Look up. You raise your hand, please, if you successfully typed the.
One of these days you just start yelling back at
Yeah, no,
him.
you should. Do it right now.
That'd be so funny.
Right, hold on. Okay, so I can't yell back because I end up injuring my voice.
You don't want us to yell back?
No, here's what we do. Listen close.
And now you go.
Listen. Okay, in a minute he's gonna do it again. He always does. He's gonna say, "Give me an amen." When he says, "Give me an amen," you gotta time it together so it's really Latin. Hey! Good work.
You do.
Much better. You do. It's way better than me yelling. I'll listen. He'll probably do it again. Hands up. Who has the 3 equations entered? Come ahead. Okay, point. Anybody need me to look at their calculator to that spot? Okay. Next thing that goes wrong. Look. Next thing that goes wrong, I've already seen it on a few calculators. You need to remember that the equal sign is an indicator as to whether the calculator will graph that equation or not. So right now I want to graph all 3, so I must have all 3 equal signs turned on. So you decide you want to turn one off, you can turn them off.
That is pretty cool.
Like this. Hey, you just highlight the equal,
Pretty radical.
press enter.
Let's go. No, that's so cool.
Now the blue will not graph.
Whoa. A word?
Word? Yeah.
Okay, Next thing, hey, listen, next thing. The calculator has, I don't know, a whole bunch of different ways to zoom. I can tell you for this class, there's one method that will get used about 95% of the time. No. Zoom fit is the one that I like best. If you like box better, it's totally fine. You can choose what you like. I like zoom fit.
Zoom 0.
So I go window,
It doesn't call that.
hit the window key.
You scroll down, zoom fit.
Okay, this chart right here, look. This chart is starting at a time of -2. It's going to a time of 7. So that's what I specify in the window. -2,
Zoom stat.
7. Then I use zoom fit. To do zoom fit, you press the zoom key,
Is 0.
and I don't want to go all the way down, so I do what HT is doing. I just press 0, which is zoom fit.
That's actually what I was
Wait,
doing.
what?
I think you're wrong, Preston.
See, I think you're wrong. You were the one that was saying
Zoom
zoom box.
Zoom 0.
The zoom box is.
You don't.
He changed his ways.
I did.
Oh, here's something most people don't know either.
I ain't even know.
When it's graphing, if you're like, oh, I want to stop the graphing because I'm tired of waiting, just press the on key, it will stop.
Bro.
Oh, there we
Yeah.
go.
Will's out here. Will's out here hating on you, Mr. Smith.
So Nadia, the zoom we're talking, Nadia, come back.
Yeah.
The zoom we're talking about is you hit zoom. If you were to scroll down a lot, you'll eventually come to the word fit.
Can you get it to go again?
No. But I'd rather not have to scroll all the way to there, so I just press 0.
I was intrigued.
Question, then we need to look at their calculator.
Found it. It's your calculator. Well, you did it regardless.
Okay, look up.
I bet.
Hey, I need all eyes on me again. Kaylee, come back. Izzy, come back. All eyes on me. Nadia, look up. Aspen, just pause for a second. You're great. Look up. You need to hear this little historical account. Okay? AP test, about the third year I was teaching, I learned that during the test, one of the students had just like emotionally lost it. Like she just started crying. Okay? Here's why. No, seriously, look, it's pretty serious. She'd spent the entire year working hard to pass the AP test, okay? She's counting on it. She knew she was prepared, so she was expecting to do well. But what happened was, something went wrong with her calculator. It started to malfunction, and she panicked. She couldn't get it working again. So let me show you, now, it turned out okay. She was able to kind of calm down and think about what we had talked about in class and got it working again, okay? But let me show you the most common things that go wrong. I would say 90% of the time when someone says I can't graph, here's the reason. And everyone do this so you can see how the error occurs, and that will help you remember it better. So grab your calculator, go y equal. It doesn't happen on the Inspire, but. And then arrow up, unless you're running it in 84 mode.
I'm in 84.
Oh, so you're good. So arrow up until plot is highlighted. And then just press the enter key and notice that plot will now become solid. Okay, now press graph.
Valid.
Yeah, that's the most common mistake.
Mine doesn't say valid. It just has a weird little blue dot thing.
Either way, it didn't work. So to fix that, you go back to y equal and just turn off the plot. People don't turn on plot on purpose, they just accidentally will get it turned on. It's
What is that for then?
It's a statistical function. So what's happening on Aspen's calculator is some student has set up the statistical stuff to be working properly, where most of you that's not set up. So the character's like, I don't know what to do. Anyway, I've never personally used it. So.
Okay.
Other questions? White first, Preston. Hey, next error that's really common. Don't type negative when you mean to type subtraction. That's common.
Classic.
Okay, don't type negative when you meant to type subtraction. After that, it's usually just type something wrong. If you are using your calculator on a test and after really 30 seconds you can't see what's wrong, you should just reset and start over. Here's how to reset. Please don't reset your own calculator, just watch how it's done, so you don't have to retype everything. So you go to y equal again. My bad, sorry, you go second, and then you choose the memory key, which is above enter. Item 7 says reset. We want all RAM, and I'm not going to do the last step because I don't want to have to reload my calculator. You would press 2, it'll reset back to fresh. Everything works again. So.
Isn't there also the tiny button in the back?
On the newer ones there is. The old ones don't have that, so I always show the menu method. So.
No,
This one doesn't. No, I did TAE.
This is when you need to look at their calculator.
I think I did something. And I don't know what I did wrong. Because everything seemed right, and I checked the. This is the correct. This is the correct one. This is fine. And I checked all of these.
You like such a George
Yeah. I checked it so.
Jake gets zooted off the bird.
Questions about anything? Okay, let's start working our way through the packet. Okay, so we got the calculator working. Stop that. You turn to the packet. The first item says that we're supposed to plot the position of velocity from time 0 to point 3. So I go back to my calculator. And I hit y equal, and I turn off the acceleration plot. So I go down to item 3, and I turn off the acceleration. Now I want a new window, so I go window, 0 to 0.3, and I zoom fit. If you do that correctly, you should end up with the graph that's on the screen. Please go.
How do you do this?
I just have it straight.
Let me come help you. I can make the thing on the board work, but it's zoomed in just to show you. So you and Izzy got inspired. That's good because you can talk to each other. So.
I did not hear any of that.
You're like half in it. No, because then I'm being fake.
Look at your window.
Okay, I want to do it. We do that in some of it. It's so fun.
So she went up here.
That is so fun. So then we go and change it from 0 to 3.
It's not loading, it's gonna post like.
Wait. Murdered.
Maybe. Oh, my class, that's pretty good. They're not worth it.
To deal with.
Not posted first.
Make it an access.
It looks like that. I can't look at it.
Did your dad say that? This one is
It's pretty tough. Could not be me. honestly. I hard ratio Mr. yesterday. Did you do the lesson yet? That's really bad. Yeah, he was doing that to me. He was like ratio with me in front of the class. I just freaking. Starts to get duckward. He's like, what do I do now?
Gets mad at you.
Not in that class period. Sarah with Brett Clark. Both Nates. One that looks like Easter eggs. That's Nate. The other Nate is Nate, Doug's friend. The one that looks like a smoker. He's pretty tall. He's a surge guy. I showed his friend where you were talking about where they're using that circle. He's got the glasses. He's still living in Boston with that hurting. He sat next to me. He's like talking about I've never seen him. There's the kids who read books all the time, about fantasy novels. The set and shit.
I can't even. It's like.
It's just two chicks I've never been in front of. Just keep Sarah at the front. The other side of the class, so we can't.
Do you know all that is? Yeah, I do. The only one of my favorite president. Do you know my mom?
It's a good class, but geez. Your ratio in that question about generational stupidity. This question is inbound in 30 different ways. He cut me off. He's like, all right, anyone else?
Let your speak for yourself. Yeah. Okay. I was like, hold on. Hold on.
I don't know. I picked up Sweden, and then I realized that's the worst feeling. I picked the wrong country for where Sweden was. And I realized it right after. Bro, not the Nate I was talking about earlier. He nailed all three of those in one. Latvia.
We couldn't get it, and then like get like 5 in a row. So the board was like, this generation of
Terrible side He tried to solve the question using the article. I was like, alright, Ella.
So he was like, you read this page, and we were reading, he's like,
Except the only name.
Anyone else give me a look at their calculator?
Yeah, wrote that huge ratioing.
Cool.
On the response in the beginning.
Right.
But I wrote a full page on the academic response. And stuff.
Okay, number one.
Created one of those 2 sentences and it said stuff.
2 ways in this class we'll typically find things on a graph. You can use the graph or you can use the main screen. You will find it useful to do both, so let me just show you both. Again, I get that a lot of you know these functions, but not everyone does. The only way to really get through it is to just show everybody. So if I go to my calculator and I want to find the velocity at time 0, I hit trace. I make sure my cursor is on the velocity. Right now the cursor is on the position, so I'm going to down arrow to get to the velocity. Once would be enough. And now the calculator is waiting for me to specify the time. I need to specify time 0, so I press 0, there it is. I'll do it one more time, then I press enter, and now I see two numbers on the screen. The two numbers are telling me the time and the velocity at that time. Wave if you need me to do it again. Just go like this. Okay. So go trace, and then find your cursor. Make sure the cursor is on the graph you're interested in. Then just type the time you're interested in. And then press enter. Questions? Please.
So you would say there's a velocity of -1 meters per second, right?
At
Y at 0.
At time 0. At time
How
0.
can you have -1 meters?
Let me illustrate. Super Terra. If you look at me, look. Okay, velocity is the rate at which the position is changing. So it's hard to go a meter because it's kind of a long step, but I'm going to go a foot. Right now, my velocity is -1 foot per second because my position is becoming more and more negative by 1 foot every second.
Okay.
Did that help?
Yep.
2 more. Anybody else? Hey, do this, please. Come on. Second quit. Press second quit, clear the screen. That puts you on the main screen. Okay, listen. You have stored in the register Y2 the velocity. We want to find the velocity at time 0. Here's the other way to do it. Hit alpha, trace. You now have a list of all the registers. Choose the one you want, which is number 2. And then type in, just like you would write, 0. Like that. Oh, because in your calculator, that's where you put the velocity.
So much faster.
So we put the velocity in Y2. So it's asking us to find the velocity at time 0. So we want to go to that equation and then time 2. Anybody else? Questions? So you need to show it again. So alpha, trace. My velocity is in Y2, so I pick 2, then parenthesis, times 0, enter, like that. Please. How do you do it on Inspire? Hold on. So one thing you want to make sure you're doing on the Inspire, I found that works better, is you're always in the document, not the scratch pad. So if you're in the document, you've got practically the window here, the graph window there. You have similar reason to open up the graph.
Speak of the devil, she isn't flesh.
Hey, let me look here. Come on, look. Did anybody else's calculator, when you go alpha, trace, not get the menu? So yours doesn't either. So I need to talk to the 2 of you after class to show you how to fix that. It's not super clear, but it's not hard either. So we'll talk after. Anybody else have trouble? Cool. So back to here. So we know this is -1. He wants to know the position at time 0. I just go back to my calculator. Main screen works great. I'm going to just use 1 now. That's position. Type in 0. It's not very interesting because it turns out to be 0. Okay, cool. Questions? Sweet, keep going. At time equals 0 seconds, how do we use the position graph to determine if the particle is moving left or right? So here's the position graph. Raise your hand, let's see who remembers the discussion. Hands up, come on. Based on the position graph, at time equals 0, is the particle moving left, right, or is the particle stopped? Come on. Sydney.
Left.
Who votes left? Point, 2 for Sydney. There's a simple phrase you can use. You can simply say, if the position graph is decreasing, the particle is moving left. If the position graph is decreasing, the particle is moving left. Particles, position graph is increasing, particles moving right. Question?
What?
Please.
How do you know which equation to use, like, when you say position? Like, is that always going to be y through?
Gotcha. So we put into the Y1 register the position graph.
Does it say?
It doesn't say, you just have to remember. The symbol, yeah, hey, don't talk. The symbol x of t is used often on the AP test to represent position. So that's just something to memorize. V velocity, A acceleration. 2 more for Lily. Please, oh.
So in the between these parentheses, right, on the second one, when I was parentheses, put in the one, gave me a different answer. So I don't really know like what parentheses.
Let me come look.
That's just a sentence there.
So this is velocity. This position. I want to know what the velocity is, but you're saying I want to know what the position is. Time is what? That position turns out to be You were down? Okay. Okay, focus. Look at me. Okay, item 4 is the most important. Look. Everybody look up. Come on, Natalie, look up. Ian, look over here for a second. Item 4 is the most important. I have rarely seen a question like item 3 on the AP test. I've seen a question like item 4 always. It's very common. They want you to understand how velocity and position are related to each other. And so if you notice, for this entire time window, the position graph is decreasing. It's going down, therefore the particle is moving left. When the particle is moving left, the velocity is always going to be negative. When the particle is moving left, the velocity is always negative. You need to memorize that. It's easy to memorize if you use Danica's chart. Because it says right here, if the position graph, if the position is decreasing, that means the particle is moving left, that means the velocity will have to be negative. When you look at Danica's chart, these symbols are all talking about y coordinates. So it's saying if the y coordinates of the position graph are going down, then the y coordinates of the velocity graph must be negative. Question. So the answer to 4 is, at time equals 0, how can you use the velocity? If the velocity is negative, the particle is moving left. It's that simple. Okay, there's no homework tonight. Don't want you doing anything, take a break, get caught up on something if you're not caught up. When I see you on Monday, or Tuesday, holiday, Labor Day, holiday. When I see you on Tuesday, we will continue working on this and then send you home with homework for this. You have my chocolate, hand it back. Rockwell, better way to say it is, position your out, numbers, tell me where the product is.
It was like up in this quadrant, it was like up to the right half of the goal left. You were watching Olympic and we can watch it. Like we can watch it. He might be happy. He might also be like, then why does she right?
Right, but is it moving towards the word?
Well, my dad,
Yours, I can
just got back from Georgia.
software and down.
We have next to each other. Yep.
Just put on.
Thank you.
So this is practically.
No, I just need it.
So from my
Minus 2
$20 per minute. However, you better.
What's your lunch? What's your A, B
Can't
set?
afford the $20. I can trade you. If you're gonna live in something, do it. Good job. For sure today. So lunch is a little bit day to day. I'm usually available. So what you do is just walk by the room, if the light's on, come in and we'll talk. If the light's off, then get something else done. And then after school for sure. Yesterday was bad. My bad. It wasn't my bad. Oh, I can only give you one because you were late. Yeah, I gotta.
Got my sister off.
Oh, that's fair. I just have to find a way to keep encouraging people to be on time.
I'll take one.
You're welcome.
See you next week.
See ya.